All right, we're going on to page 3. So, a passenger train and a freight train leave town at the same time and travel in opposite directions. Their speeds are 60 miles per hour and 75 miles per hour, respectively. How long will it take for them to be 297 miles apart? I gotta love these distance problems, right? Now, the most important part of this is making sure you have your formula. So remember, anytime you talk about distance and speed and time, it's always the same thing. Distance equals rate times time. Now, we can use our table format again for these problems as well, because we want to look at each individual train separately and then look at their combination together. So the way we had it set up before was you have your rate in your first column, you have your time in your second column, and you have your distance in the third one. So, excuse me. If we first start with the rates, we know we got our two rates there, 60 and 75. So I'll put my line down under that. The one thing that they tell you is that they leave town at the same time. So that's important. So you're starting the clock and they both are starting to move, and then you stop the clock and they both stop exactly. So they're traveling for the same amount of time. If they're traveling for the same amount of time, we can use the same variable for both of them. So that's important. If one started a little bit later, we'd have to alter one of these times. But because they're starting at exactly the same time, we can use the same variable, same t. Now we're almost there. D, remember, is just the product of those two variables. So we're just going to multiply straight across, and we get our distances. So we get the distance for the one train, we have the distance for the other train, and then how much distance do we want both of those two trains combined to be? You got it, 297. So now we can just add those two distances together to get our total distance of 297, and now we're on our way. So 135t is 297. Let's divide that, and let's see what we get. 297 divided by 135, 2.2. So 2.2 what? Yeah, look at their speeds, miles per hour. So this time has to be in hours. All right, not too bad. But again, those tables are very powerful if you can get them set up correctly. So let's take a look at some of the other applications. So this was a classic one. Which is the better buy for processed cheese slices? 16 slices for $4.38 or 12 for $3.30. Give the unit price in each case. So remember, how we found unit price was a special formula, not super special, but the biggest thing you have to remember is that it's always price over quantity. So price over quantity. So we got to put the 438 on top, divide that by 16, and let's see what we get. 4.38 divided by 16 equals 0.27375. Now, do you need all those decimal places? Well, it's a real tempting to want to round it to 2 because it's money, right? But I like to go extra just in case per slice. So it's around 27 cents, a little over 27 cents per slice in the first case. So that would be what we should write on the blank. I'm going to just abbreviate SL. And then let's see what the other one is. So if we did $3.30 divided by 12, Ooh, so you can see why rounding into 1 decimal place is, or 2 decimal places is a little bit precarious, just because the prices can get close. So, well, so which is the better buy? The cheaper one, of course. So that must mean the 16 slices for $4.38. Not by much, but it is a little bit cheaper. So, all right, let's go into number 9. The distance between Boston and Milwaukee is 1,050 miles. On a certain map, this distance is represented by 21 inches. On the same map, Seattle and Cincinnati are 46 inches apart. What is the actual distance between Seattle and Cincinnati? Now, whenever they have this kind of zigzag of relationships going on, you can always use a proportion. So the first thing we know is that these two quantities go together. 21 inches is the same as 1,050 miles. So we can use that as 1/2 of our proportion. Now, it doesn't really matter which way we have it set up. You can put the 1050 over 21 or vice versa. But it will give you the same result. What matters more is what you do on the other side. So we don't know what the actual distance is, so that's going to be our x. But the distance on the map is 46 inches. So where should that go? On the top or the bottom? It's going to have to go on the bottom, right? Because we got inches over here, we got inches here, we got miles here, and we got an unknown amount of miles there. So remember, those units are really going to be beneficial to helping you set up that proportion correctly. So just be careful. Well, once you have it set up, now it's all downhill. Now we can cross multiply. So let's start with the unknown cross product first. So 21x equals 1050 times 46. So I don't know what that is. So let's use our calculator to see. 48,300. And now if we divide that by 21, we get 2,300. So 2,300, and what are the units? Don't forget the units. 2,300 miles. So that should be that actual distance. All right, a little bit shorter, but we still got some more pages to go. So see you in the next videos.